In this video, we're going to look at the third type of trigonometric transformation, which is a f of x. So what we're doing here is we're multiplying the function f of x by some constant value a. And what this transformation does is that it stretches the graph vertically by a factor of a, or in other words, it stretches parallel to the y-axis by a factor of a. And if the value of a is greater than 1, it's going to be a stretch. And if the value of a is less than 1, it's going to be a compression. So let's look at an example. Here I have the function f of x is equal to sine of x. This is the graph of sine x. And let's say I multiply this function by 2. So it would be 2 f of x is equal to 2 sine x. And the graph of 2 sine x, what's going to happen here is that each value of y is going to get multiplied by 2. Because f of x we can write as y, and what's happening over here is that each value of y is getting multiplied by 2. So this graph is going to stretch vertically by a factor of 2. 1 times 2 is 2, and let's say that this point is 0.5, and 0.5 times 2 is 1. So this point would go over here. Similarly, this point would go over here. This point is at y is equal to 0, and 0 times 2 is just 0, so this point is going to remain over here. Similarly, this point is also going to remain over here, and this point, which is at -1, is going to get multiplied by 2 because my value of a is 2. And I'm stretching my graph with a factor of a. So this point is going to go over here. Similarly, the points at -0.5 are going to go at -1. So after this transformation, my graph is going to look like this. Now let's look at an example of compression. We know that if the value of a is less than 1, it's going to be a compression. So if I multiply this function by a value less than 1, let's say 0.5, so it's going to be 0.5 f of x is equal to 0.5 sine of x. So each value of y is going to get compressed by a scale factor of 0.5 because the value of a is 0.5 and we stretch or compress by a scale factor of a. So this value of y at 1 is going to get compressed by a scale factor of 0.5. So if I multiply 1 by 0.5, I would get 0.5. So this 1 would go to 0.5. And this point, which was originally at 0.5, if I multiply 0.5 by 0.5, I'll get 0.25. So this point is going to go further down at 0.25. So my graph is going to get compressed like this. So after the transformation, my graph is going to look like this. You can see that the whole graph has been compressed parallel to the y-axis. Now in summary, if we multiply the function by a value greater than 1, it's going to be a stretch vertically. And if we multiply the function with a value less than 1, it's going to be a compression vertically. But if we multiply the function by -1, then my original graph is going to get reflected about the x-axis. So this point, which is at 1, if I multiply 1 by -1, because in this transformation we multiply the value of y by the value of a. And if I suppose that a is -1, I am finding minus f of x, which is going to be minus sine of x. So for the graph of minus sine x, I am going to multiply each value of y in the graph of sine x by -1. So 1 times -1 is -1. So this point, which was at 1, is going to go to -1. And this point, which is at 0, is going to remain at 0 because 0 times anything is 0. This point is going to remain as it is. And this point, which was at 0.5, 0.5 times -1 is -0.5. So this point is going to go over here. Similarly, this point is going to go over here. So the graph of minus sine x is going to look like this. This orange graph is the graph of minus sine x, which is minus f of x. So if the value of a is -1, it's going to be a reflection about the x-axis. Now let's look at more examples of negative values of a. Let's say that if a was minus 4, so I'm looking at minus 4 f of x, which means minus 4 sine x. So how is the graph of minus 4 sine x is going to look like? Well, in my original function f of x is equal to sine x, each value of y is going to get multiplied by minus 4. So this point which was at 1, the value of this y coordinate is going to get multiplied by minus 4. So 1 times minus 4 is going to be minus 4. So this point which was at 1 is going to go to minus 4, which is over here. Similarly, this point which was at 0.5, I am going to multiply with minus 4. So 0.5 times minus 4 is minus 2. So this point is going to go over here. Similarly, this point is going to go over here. This point which is at 0, 0 times minus 4 is just 0, so this is going to remain where it is. This is also going to remain where it is. And this point which was at minus 1 times minus 4 is going to be positive 4. So this point is going to go to positive 4, which is over here. So after this transformation, my graph is going to look like this. So this graph, this purple graph, is the graph of minus 4 sine x, or minus 4 f of x. So this was this transformation for the function sine x. Now before looking at this transformation for cosine x and tan x, we are going to look at a term called amplitude. And the meaning of amplitude is that it is the height from the center line to the maximum point or to the minimum point. So this graph of 2 sine x, the function sine x has the coefficient 2. So the amplitude of this graph is 2, because the height from the center line to the maximum point or to the minimum point is 2. Now let's look at the graph of sine x. This function sine x has the coefficient 1. So the amplitude is 1, meaning the distance from the center line to the maximum point or to the minimum point is 1. And another point to note over here is that the amplitude is always positive. So if the graph is of minus sine x, the coefficient here is minus 1. But I will take the modulus of this minus 1, which is going to be positive 1. So the amplitude is 1. And you can see on the graph of minus sine x also, the distance from the center line to the maximum point or to the minimum point is also 1. So this was the amplitude, and the amplitude is the coefficient of the trigonometric function. Now let's look at examples of these transformations for cosine x and tan x. Here I have the graph of the function cosine x, and if I multiply this function by a value of 3, let's say 3 f of x, so it's going to be 3 cosine x. And for this transformation, I'm going to multiply each value of y by 3. So this point which was at 1 is going to go to 3, and this point which was at, let's say 0.5 times 3 is 1.5. So this point is going to go over here. And this point which was at 0 times anything is 0, so this point is going to remain where it is. And this point which was at minus 1, after getting multiplied by 3, is going to go to minus 3. Similarly, this point is going to go here, this point over here, and this point will remain here. So after this transformation, my graph is going to look like this. And the amplitude of this function 3 cosine x is 3. You can see the distance from the center line to the maximum point of this graph or to the minimum point of this graph is 3. Now let's look at what happens when a is minus 1. So the graph of minus f of x, which is minus cosine x here, is going to be the reflection of the graph of cosine x about the x-axis. This is my x-axis. So this graph, after getting reflected about the x-axis, is going to look like this. This is the graph of minus f of x, or minus cosine x. And the amplitude of this function minus cosine x is 1, because for the amplitude we take positive value of the coefficient. Now let's suppose that if a was minus 3. So I am looking at a graph of minus 3 fx, or in other words minus 3 cosine x. Each value of y on my original graph of cosine x is going to get multiplied by minus 3, because the value of a is minus 3. So this point which was at 1 is going to go to minus 3. these points at 0.5 are going to go to minus 1.5, and this point which was at minus 1 is going to go to positive 3. So this graph is going to look like this. This is the graph of minus 3 f of x, or minus 3 cosine x here. And the amplitude of this function minus 3 cosine x is positive 3, because we take positive value of the coefficient of the trigonometric function. And you can see over here the distance from the center line to the minimum point or to the maximum point is 3. And that's what the amplitude is. It's the distance from the center line to the maximum point or to the minimum point. Now for the final example, here I have the graph of tan x. This is the function of tan x here. Now for this transformation, let's suppose that if a is 2. So the graph of 2fx, meaning 2 tan x, is going to be a vertical stretch of this graph by a factor of 2. So this graph is going to look like this. Here this point which was at 1 went to 2, and this point which was at 2 went to 4, because 2 times 2 is 4. Now you can see over here for this graph of 2 tan x, there is no maximum point or no minimum point like there is for sine and cosine functions. And if there is no maximum or minimum point, I cannot find the amplitude. So the point to note over here, for tan functions there is no amplitude, no matter what the coefficient is. Here the coefficient of tan x is 2, but the amplitude is not 2, because there is no maximum or minimum point. So in tan functions there is no amplitude. And if a is minus 1, we know that when a is minus 1, for this transformation the graph gets reflected about the x-axis. So if a is minus 1, the graph of minus fx or minus tan x is going to look like this. Here this dotted line is my original graph of tan x, and this solid line is the graph of minus fx or minus tan x. Now for this minus tan x, the coefficient of this tan function is minus 1. You could say that the amplitude is 1 over here, but remember for tan functions there is no amplitude. So this concludes our third transformation of vertical stretch or compression. In the next video we'll learn the fourth and the final type of transformation, which is horizontal stretch or compression.